All right, we'll go ahead and get things started here. This is the ArcGIS Velocity and Introduction presentation. Thank you all for coming here to talk with us today about velocity. My name is Peter Nasuti, and I'm the ArcGIS Velocity product owner of the real-time big data team at Esri.
I'm Tyler Moon. I'm a senior software engineer on the team.
So before we get underway here, I just remind everyone, please use the Esri Events app. Give us feedback after the session. We take it to heart. We look at it every year and adjust presentations accordingly. So if there's something you wanted us to talk about that you didn't see, let us know for future presentations. So today, as we know, we're all living in an increasingly connected world. So many of us have multiple connected devices between home and work computers, mobile phones, smartwatches, fitness trackers, the list goes on and on. But what's been changing in recent years is the onslaught of smart devices that can track and monitor almost anything, whether that's a fleet vehicle to equipment, shipping containers, networked factories, industrial systems, environmental sensors, and much more. So these sensors are getting smarter and more pervasive, but they're also getting cheaper, which means more and more organizations are looking to deploy them and then leverage the data they can find from them. That means there's more and more real-time geospatial use cases and an increasing number and variety of organizations encountering these use cases. Let's talk through some of these cases. So starting at the top left, personnel tracking is one of the most common ones that we see. Apps on phones can collect location data, as can a wearable device, and organizations are interested in monitoring things like staff locations for safety or to ensure that assigned work is being completed. In some of the more advanced cases, employee tracks are used to optimize your field operations. This notion of resource optimization is also found in fleet and asset tracking. Many customers have tracked their entire fleets with GPS devices for many years, and now sensors are even being monitored on valuable equipment to keep track of its active location and its assigned objective. For example, instead of just monitoring truck locations, now organizations might even put a tracker on something like a generator at a construction site to know exactly where all of their assets are. Hazard and threat monitoring based on location is another use case where real-time data is key. Historically, hazard monitoring has been primarily done with weather feeds against critical infrastructure or facilities, but now these feeds are much more current, and there's a lot more than just weather out there. There's transportation, social, crime data feeds available, and organizations want to synthesize all of this to know where any potential hazards or threats might be. Another key use case is SCADA system integration and operations monitoring. These are missions common in the utilities and the natural resource industries. And in the agricultural and environmental sectors, there's things like soil, crop, air quality, water flow monitoring, and much more. And in addition to this, there's new types of real-time sensor data emerging in transit and transportation, like connected car data that helps us understand traffic patterns at new levels of detail, or fleet tracking, such as not just knowing where is your snowplow right now, but knowing even more fine-grained information, such as is the snowplow up or down, or is it actively spreading salt or brine from the rear of the snowplow and at what rate? There's a wide variety of things here, but what all these use cases have in common is that they require real-time data that's tied to location, and in this increasingly connected world, the speed of the data is growing rapidly. And many industries are looking for a platform to ingest, analyze, and act on changes and activity out there in the world. So to service any of these use cases, especially with data at higher rates, you need to be able to do some fundamental things. The first step is to ingest your data in real time so that that data can be visualized and interpreted. The second is to analyze the data continuously to identify incidents, understand current state, and often to store the data over time for historical analysis. The third thing is to alert the right individuals or systems depending on your organizational criteria. And the fourth that we can often see as well is to actuate when the results of analysis need to translate into physical action or change, or also to send the data onto another system or notify someone accordingly. ArcGIS Velocity is built around these fundamentals as a framework in which these capabilities can be configured as needed for the nuances of your specific use cases. So ArcGIS Velocity provides real-time and big data capabilities for the ArcGIS Cloud across these areas. It includes a wide variety of feeds and sources for ingesting data. connecting to different sources of real-time data, handling different formats, and scaling to satisfy higher data rates. It also enables you to automate analytical processes on any cadence. You can perform streaming analysis in real time, batched analysis in near real time with scheduling, and also analyze large and vast volumes of data that you've collected over time. You can take different kinds of output action, including alerts, and to send data onto other systems to trigger another business process, or to actuate by sending analytic output to desired APIs or cloud outputs that translate to physical action in the real world. So ArcGIS Velocity is the software as a service offering within Esri's real-time visualization and analytics capability. In many ways, it's a sibling product to offerings that we have for ArcGIS Enterprise. It includes GeoEvents capabilities for real-time data ingestion and incident detection, but also big data pattern analysis capabilities from GeoAnalytics server, where many tools are shared. Velocity provides these capabilities in a cloud-native software as a service that can scale to higher velocities and volumes of data, especially without the on-site configuration and maintenance inherent to deploying an enterprise system. So you can think of Velocity as sitting on the edge of Esri's geospatial cloud. It can connect to Internet of Things platforms, messaging brokers, and third-party APIs for sensor data, but it does not typically integrate with sensors directly. Users directly configure feed items to receive streaming data inputs. Real-time analytics allow users to apply real-time tools to that data and output results and alerts and actions. And with big data analytics, users can access and analyze big data repositories of your historical observations. These analytics generate geospatial content like stream layers, feature layers, and map image layers, which can then be leveraged throughout the ArcGIS platform in client applications, APIs, desktop applications, and more to drive additional insight and situational awareness. In this way, ArcGIS Velocity is very much an engine which automates and runs your tradecraft that's been authored by users or your subject matter experts. So all these feeds and analytics that we're talking about are all configured within the Velocity web application. As ArcGIS Velocity is very much an engine, a cloud system that runs your real-time and big data jobs, the app is an authoring experience for these capabilities. We also expose a product API and some elements and functions in a Python API for those who wish to further extend actions in a programmatic way. And these item types, feeds, real-time analytics, and big data analytics address the essential real-time challenges of ingesting, alerting, and analysis. So now I'll hand things to Tyler, who's going to show us how to create a feed in ArcGIS Velocity using real-time data and have a quick look at what kind of result you get.
All right, thanks, Peter. So what we're looking at here is the Velocity UI, and you can see we have the different categories that Peter was just describing. We have feeds, real-time analytics, big data analytics. For this demo, we're going to specifically be looking at feeds, which are a way of ingesting data into the platform, and the different ways that we can connect to it. So we're going to go ahead and start with looking at the output of what we're going to be building as this demo. As you can see here, this is a map of Washington, D.C., with buses being displayed on the map. And every periodic, they're going to be moving around, reflecting the data changing underneath, so that it's changing in real time. This is coming from the Washington Metro Transit Authority. Their API is exposing this data that we can then grab the positions. We can also see a bunch of other attributes per data point. So let's go ahead and go into Velocity here and take a look at the feed. And we'll go ahead and create a new one just to show you how we can configure one. So we'll go into feeds, we'll go create feed. There's a bunch of different types of feeds that we can do depending on where your data is at and what your data looks like. So we can come from ArcGIS, we can connect to cloud systems, we can do web and messaging, which is kind of the more common ones. And then we even have some data providers depending on where your data is coming from. For this specific demo, we're going to look at the HTTP poller method. This is one that will pull a specific HTTP endpoint on a recurrence. So you can do it 10 seconds, you can do it 5 minutes, those type of things. So we'll drop in our API. We can see we can do get or post actions. We can do different authentication types. and we can pass in URL parameters. In this case, we want an API key specifically. So we're going to paste in our API key, and then we'll go on to the next page. This is now going to try to detect the schema of the data that you have. So it went ahead and pulled that API. You can see here we have a bunch of JSON in our sampled values, and really it would be more helpful to have those as individual fields. So we can change our root node to be the bus positions object, and now all of our properties are there. Now we have to tell the feed what type of data is going to be used for XY positions, and which of our fields is going to be used for date and time. This is how we can enable it to do analysis on position or time properties. And we're going to have to put in our date format so we can make sure that all that gets formatted. The last thing we're going to do is a track ID, which allows us to denote specifically which bus we're looking at. And now we're going to schedule it so that it will run every, we'll do 10 seconds, which is the fastest we currently allow. And so every 10 seconds it's going to hit that API and grab the data and pull it into our system. So we'll go ahead and title our feed, and then we'll create it. Once this is created, now you can see that it is initializing, so it's setting up everything on the back end and getting it ready to go. You can also see we have all of the details we just inputted are just stored on the bottom there. And if we give it just another little bit here, it should finish initializing and start pulling in data every 10 seconds. There we go. So now it's booted up, and you can see it's running at 0 features per second. And on that map there should be showing us a preview, and there's the data coming in. So the little dot. If you hit open in map viewer, then you can actually view it in a regular map view. And that brings us back to where we started earlier with our buses being positioned on the map. And so that's it for our demo today of how to configure a feed in Velocity. Peter, turn it back to you.
Thanks, Tyler. So what you just saw there is the first step in leveraging real-time data, which is accessing your data and bringing it into ArcGIS Velocity. There's thousands of sensors on the market today, and being able to connect to that data and use it oftentimes involves vendor-specific data applications that are siloed or might require custom-built solutions to read it and integrate it with your enterprise systems. Configuring feeds in ArcGIS Velocity is an easy-to-use guided workflow that lets you directly and seamlessly connect to external sources of observation data, like Internet of Things IoT platforms in the cloud, message brokers, gRPC or HTTP receivers, or third-party APIs. The feeds automatically derive the schema of your data and allow you to revise your data and specify your data model on the fly of exactly what data from that you want to pull in, and then simply add it to a map to immediately see the real-time information and combine it with other data. This is both situational awareness and system integration, configured in minutes without writing any code. So bringing in data with feeds is really just your first step. With real-time analysis, you can do more than visualize your sensor data, you can immediately put it to use. So in Velocity, the feed is an input to a real-time analytic, which can be used to transform, enrich, and detect incidents, and more. Real-time analytics are a flexible model building capability that lets you combine different tools and take different kinds of action. You can store sensor observations over time to a feature layer. You could send notifications and alerts, and you can even send commands and triggers to external systems to actuate behavior. So now Tyler's going to show us how we create real-time analytics in ArcGIS Velocity.
So we're starting here from where we left off with the feeds. So this is our bus positions coming in. And what we're going to want to do here is take this data and not just display where the buses are, but instead display where the broken status buses are, so ones that are reported broken, and also calculate how far away they are from the nearest maintenance facility. So in order to do that, we're going to jump back into Velocity real quick. We're going to head down to the real-time analytics section. This time, for just simplicity's sake, we're going to start with a real-time analytic that I've already created, but we'll step through it so that we can see how that they work. So here's our analytic, and we're going to go ahead and edit this analytic. And now we can see through our UI how everything is configured with a series of tools. So we're first starting off by taking in a feed. So this is our bus data position coming in from the feed we created earlier. And we're going to combine that with a feature layer that is displaying where our broken status buses have been reported. And using a join features tool, we can join those two data sets together with the vehicle ID. So that way we can make sure that they're matching up one-to-one. So we're matching on the vehicle ID to create a unified data set. In order to kind of visualize this a little bit better, we can turn on additional metrics in Velocity. So now we can see feature rates flowing through the system, and we can see that data is coming in from both of our inputs going into our joined features. In this case, we only want to see the buses that have a broken status, so we can use an arcade expression to quickly take the vehicle status and only grab the ones that are in broken. Those are the ones that we're interested in. And so you can see that it's pretty easy to just put in a quick expression right there, grab whatever data set you need. If we go back to the join features real quick, we can go ahead and sample the node data. So because the feed is running, we have data flowing through this right now. And we can sample it to take a look at just one brief snapshot of that data. And in here, because we're on the join features, not all of the buses have a broken status on them yet. So you can see that one did not have a broken status. But if we go ahead and take a look at the filter by expression, and we sample the data coming out of that tool, we should be able to tell that only broken statuses are coming out of it. Now this is a pretty simplistic example, but hopefully it illustrates the point that with these filters and joins, you can really grab only the data that you're interested in, regardless of what data came in the first place. So you can see we have a broken status, and we also have a broken status there. So from that filter, now we can output it directly to a feature layer. So we have a feature layer of just the positions of buses that have a broken status being reported on them. And that's a useful capability in and of itself. But we can also combine that with a feature layer of where all the maintenance facilities are and run that into another tool to calculate the distance. So this will calculate the nearest distance from a point on the maintenance facilities feature layer to the point that came in from that filter by expression, the broken buses. And so that's what we're doing here. And you can see that we have grabbed all of our data. We're now going to control the event volume. If we have a broken bus, we don't need to be notified every 10 seconds. So this is going to slow down the rate so that we only get notified once every 2 minutes. From here, you can see that we can use a variety of different outputs. So this top output here is going to be another feature layer of here's your broken buses with their closest facility. This next one here is connecting to AWS SNS. So that's simple notification service. In this case, we're using it to send out emails. So that way we can notify somebody, hey, there's a broken bus here. So if we go ahead and look at this SNS and we hit edit, you can see we're again using another arcade expression to grab data from the event that came through and use that for the message body of the email. So this means that we're not just sending a generic, hey, a bus broke down. We're sending a message that says, this specific bus broke down and it's this far from the maintenance facility, and here's the time at which it was reported. So you can really get specific to use those properties in your notifications. And so now we can go ahead and close out of that window there, and that is the simple notification system. So here's an example of what one of those emails could look like. Pretty basic email, but it gives your users the notification that, hey, this is what's going on in the system. Another output type we have is text message. So if you need to have real-time text message alerts go out, you can also send those out. And if I pull it up real quick here, this will be an example of what those text messages will look like. You can just get bombarded with text messages like I did making this demo. And so that's how we can configure multiple different outputs to come in from the big data analytic. And this is the ending result of the map view. So now we can see, instead of having all of the buses everywhere, we only have the subset of buses that we're interested in. And you can see that distance to feature has been added. So that's the distance to the maintenance facility. And so this is how we can configure the real-time analytics to be able to take those feed data, do some more analysis on it, and then output it again. And that's it for this demo. So back to you, Peter.
Thank you, Tyler. So these real-time analytics provide processing power to your tracking and your sensor workflows. Instead of having to build a custom-built application that needs to incorporate some complex analytic streaming code bases, any end user can assemble an end-to-end workflow to detect incidents, capture data, enrich data, and much more, exactly as they want, with various pipelines and various outputs along the way. These real-time analytics process each message from a feed continuously as they arrive, meaning every time a message comes in, it's immediately processed through the real-time analytic, and they can leverage static data sources as well to serve as geofences or enrichment data. Furthermore, real-time analytics can compare different feeds of live data against each other to generate true real-time insights. For example, comparing the spatial locations of one real-time stream of data against another real-time stream of data. You can combine different tools together in a workflow to ask any number of questions and associate different output behavior with each one. In some cases, you might store data, whereas in others, you might send alerts or a command to a third-party system. These real-time analytics are useful when your decision timeline is operational, when you need to know about something and act immediately. Velocity supports these kinds of patterns because there's a focus on integration with external systems. There's extensive support for different real-time and big data systems and various data formats. The aim is at covering major commercial IoT platforms as well as common real-time messaging technologies. The approach, especially for real-time scenarios, is to also aid at getting your data into and usable within ArcGIS. In other words, the data doesn't already have to be in an ArcGIS layer to be leveraged. If you're detecting incidents and finding patterns, you can use those findings within other systems through these different supported outputs. For example, MQTT can be used as a bridge to bring in vehicle tracking data from an AVL sensor vendor, and an Azure or AWS IoT hub could be leveraged to access data from a SCADA system to make it available externally or internally within your organization. And polling a website through the HTTP polar feed and source types allow you to access many vendor APIs to bring in the data from whatever vendor you're using specific to your organization and your use cases. So beyond real-time visualization and analysis, you can also work with the information that you store over time. So as we know, feeds bring in and visualize your real-time data, and these get used in your real-time analytics for immediate awareness of incidents. Real-time analytics, of course, can store your observations and data over time to a feature layer. They could write to a ArcGIS Online hosted feature layer, an ArcGIS Enterprise feature layer, or an ArcGIS Velocity feature layer. As data arrives in real time, these historical data sets can grow to large volumes very, very quickly. So if we are bringing data in at 100 messages per second, that's going to grow to 9 million records within one day. And for that reason, ArcGIS Velocity is designed to grow with you. The ArcGIS Velocity layers can store hundreds of millions of features within them. It includes configurable big data analytics so that you can also then process this information for trends. These big data analytics can be run ad hoc. When you want them to be run, you click start, they run, they do their processing, and they finish. But they can also be scheduled and run in near real time to support different workflows. So I'll hand things back to Tyler, who's going to show us big data analytics now in action.
All right, so here we are. We're looking at output from our real-time analytic. So now we're going to change and do analysis on the data that we've been collecting from all of these buses. And in this big data example, what we're going to be wanting to do is determine for each route of buses, what is the standard deviation between the fastest bus to do it and the slowest bus? So that way we can determine maybe there's some differences in the different routes, and what does that look like over time? Are there some routes that are more variable, some that are always consistent? What does that look like? So as you can see, we're scrolling through on the bottom here over time, but we're going back. So this is taking our real-time data and allowing us to do analysis over the past hour, past day, those type of scenarios. And so this gives us the same functionality where we can click on a specific route and we can see all sorts of metadata about that data. And so now we're looking at the bus data, but aggregated to the route. And so that's what we're going to be able to do with this big data analytic. So if we go back to Velocity, we can take a look at the big data section. And then we can go ahead and edit one of these that already exists. And we'll see a very similar workflow to how the real-time analytics work. The UI is very similar. The tools are different, but the way that you interact with them is basically the same. So what we're doing here is we're taking in a feature layer of historical bus locations, and we're going to be able to run 2 different paths on it. So here's our feature layer with all of our bus positions coming in. We're going to run another filter by expression. This time we're going to only grab data that has been added in the past 24 hours. So we're only looking at what was the last day's worth of data. And then we're going to split into 2 different sections, one field map and then one summarized attributes. We'll go through both of those. On the summarized attributes here, we're going to take that data and determine a number of different summary fields. So we're grouping by the route ID instead of the vehicle ID. And so for the route, we're going to determine what the min, max, and average, and then also the earliest last bus, and how many buses were on that route for that given time period. And so that'll group all of our data together, and we can output it to 2 feature layers. The first one would be the daily record. So this is going to overwrite every time we have more data added. So this will only keep the last time that we ran this big data analytics data. And so this would be useful for looking at what was the last run, what was the data from that. But we can also output to a second feature layer and set our retention policy to 6 months. So now we can store our data for longer, and we can do additional analysis on it later if we wanted to look at a month-by-month or 6-month trends, those type of things. On the other side of this analytic, we're going to be looking at the map fields. So in this case, we're going to take all of the fields and combine 2 of them together to make a new trip ID with date time. You can use this for renaming fields if you need to rename them, combining them, those sorts of actions, which is pretty useful to be able to manipulate your data to get it in the form you need. Then next, we're going to run it through a tool that will reconstruct the tracks. So this will take the individual points of data that we had for positions and use that trip ID with date time that we just added to create a route. So now instead of having a single point data, we have a line of data representing a route over the specific hour time frame. And so that's how we can then get our data together. And then we can output that straight to a feature layer. So again, a lot of these will have many different feature layers outputted. So depending on which part of the analysis you're trying to use dictates which big data analytic you're going to want to look at. So the output that we're looking at now is the one that we started with, which is our end goal. We can summarize it again so we can grab even more of those data. This is similar to what we were doing before. And then we can also output to 2 more feature layers. This is similar to the output earlier. One of them is the current daily records. The other one is the historical records of the past 6 months. So that way we can do even more analysis on top of it. And so that's what a full big data analytics job can look like. You can make many different paths down it. You can output many different ways. You can have a lot of different input sources and all of those type of things on doing analysis depending on whatever your use case is that you need. And I think that's pretty much all that we have for that demo. So we'll go ahead and hand it back to you, Peter.
Thank you, Tyler. So these big data analytics that Tyler showed are parallelized Spark-based processes. And as you saw, they're put together in visual programming, model building experience, just like real-time analytics, so that no coding is necessary. Much like our real-time analytics, you can stitch together different tools in an overall automated process and create multiple information products at the same time on the same data. You can analyze data already in ArcGIS layers, or you could pull data in from cloud stores like Amazon S3, Azure Blob Store, Azure Cosmos DB, and more. Results certainly can be sent to ArcGIS layers for visualization, but Velocity is also an IoT-oriented system, so you can configure a big data analytic to emit a result to an external destination. This isn't necessarily something you would do in the example that we showed, but depending on the use case, you could run near real-time analysis on spatial trends across your network and use that to drive alerting or even triggering a work order in another business system. So on the screen now, you can see all the different tools that are available in real-time and big data analytics within Velocity. The ones that have a yellow star beside them are only available in big data analytics. This wide variety of spatial temporal tools that are included in Velocity includes tools for summarizing data, detecting different types of incidents and behavior, analyzing patterns, and leveraging spatial proximity. And these are many of the same tools that are available through geoanalytics. But this also includes tools and concepts from GeoEvent Server that focus on tracking and movement analysis, like calculating motion statistics, summarizing journey and trip information, and snapping tracks to your road networks. All of these tools up on the screen can be used in big data analytics, and those that can operate on a single message at a time also work in real-time analytics. So both types of analytics in ArcGIS Velocity can generate output layers for visualization of spatial and time-enabled data. And there's three basic types. So stream layers visualize new data right as it arrives. Here we're looking at city buses moving around on their routes. And these stream layers are based on WebSocket technology so that your map client is actively connected to the underlying real-time server, and data is sent along that WebSocket instantaneously as it's available. Feature layers visualize data once it has been stored and are the most common layers seen across the ArcGIS platform. To visualize data from your feature layers in near real time, you can set a refresh interval on your mapping client so that you can re-query for new information every few seconds. Additionally, we talked about larger feature layers and how fast data can build up in Velocity and quickly reach millions and tens of millions and hundreds of millions of records. When you create a feature layer in ArcGIS Velocity, it also creates a special kind of map image layer. And this map image layer supports dynamic aggregation of high volume data so that you don't have to try to render and draw millions of features individually. These on-the-fly aggregations refine continuously as you pan and zoom, showing increasing levels of detail, and then transition over to show the raw features when you have a reasonably low number of features in the map extent, and the user zoomed all the way in to maybe the street level, and now they want to see individual features. So all three of these layer types can be created through the analysis tasks and then used in dashboards and apps to visualize this information through maps, widgets, gauges, and much more to improve situational awareness. So as we wrap up here, we just want to reiterate a few things. ArcGIS Velocity is a configurable real-time and big data engine for ArcGIS. It extends ArcGIS with the ability to bring in real-time data from various different platforms and then put that data to immediate use. These key capabilities of Velocity include ingesting your sensor data with a wide support for different messaging systems, data formats, and data velocity. You can automate analytical processes and tradecraft on that data, whether it's in real time, near real time with scheduling every 2 minutes, 5 minutes, every hour, once a day, or massive amounts of data over time. Additionally, the capability to drive specific action from analytical results, such as alerting the right parties or actuating physical changes in the field or at a facility. This is all configurable with familiar and powerful spatial analysis tools and can be applied to use cases from personnel tracking to asset monitoring to infrastructure protection. So as we exit here and move towards questions, I want to make everyone aware of a lot of the different resources that are available. Of course, we have documentation pages like all of Esri products, and there's some getting started pages in the documentation that show you step by step, click by click, how to create your first feed, how to create your first real-time analytic and big data analytic, and more. We have additional tutorials linked as well. And then we also have the blog and the community. So of course, the product team's here. We're here now to answer questions. We'll be at the booth throughout the rest of the week. But if you leave the conference and then you want to get in touch with the product team, you have a question about Velocity or GeoEvent or real-time and so forth, I'd encourage you to go to the Esri Community. All of our team members and product engineers get alerts whenever something's posted in the real-time space, and it's a great way to get in touch with the product team outside of a conference. I'd also show those of you who have interest in learning more and seeing more about Velocity and also real-time as well. This is our only session today, but we have 2 sessions on Wednesday and 2 sessions on Thursday we'll go into a lot more depth. Tomorrow for Velocity, we'll show stateful real-time analysis using Arcade, which is where there's a lot of configurability and kind of custom control over building effectively your own tools within the ArcGIS Velocity tools to look back at track observations and perform calculations. And then on Thursday, we have a session showing custom data ingestion with gRPC and HTTP for those cases where if somebody wants to bring in data from a certain system that doesn't necessarily have an out-of-the-box feed type right now at this point in Velocity, there's various pathways to have that data basically pushed into ArcGIS Velocity through the gRPC and the HTTP receiver feed types that we have available. And I'd also encourage all of you to please definitely share feedback in the app, and we'll incorporate that in future sessions. And that will take us to questions. So we're happy to take all the questions that everyone has. Thank you for your time. So it's tough to see with the lights. So if you have a question, just kind of wave your arm or come up to the microphones. If you speak up, we'll repeat the question back. If you speak up so we can hear you, you can stay there.
So is ArcGIS Velocity real-time analytics intended to replicate the event capability one by one? And if not, where do you draw the line on when to use the event and when to use velocity?
Yeah, it's a great question. So the question was, is ArcGIS Velocity intended to replicate what GeoEvent offers one-to-one, especially with the real-time analytics? And basically, when would you use Velocity and when would you use GeoEvent Server? So they're not designed to be identical in that sense. GeoEvent has been around for over 10 years now, and it was designed on a different technical stack underneath, right? So when Velocity was developed, it was developed around a few key ideas. The first of all is starting with software as a service so that it's available not on premises, on enterprise where you have to have an administrator install it and maintain it, but available on the cloud. So if your organization wants to get started with Velocity, it can be up and ready within an hour, right? And there's no user-managed upgrades or maintenance. That's all handled as a software as a service on your behalf. Whereas GeoEvent is only available in an enterprise where it's software. It's not software as a service. It's software that you have to install onto a server and upgrade it and maintain it, administer it, and so forth. So oftentimes the conversation where people decide which they want to use is they ask themselves, do we want software or do we want software as a service? And does it have the capabilities that we want? As you saw, Velocity has a much more modernized user interface, and we've heard feedback definitely from users that they find it easier to get up and running with Velocity because GeoEvent's designed more around administrators and power users and so forth. And we've took a lot of the learned lessons from GeoEvent and whatever people struggled with and pain points that people had with schema and GeoEvent definitions and so forth. And we brought that into the design of Velocity, which you saw some of Tyler's feed configuration, where we help the user as gently as possible through the schema identification and configuration steps to kind of bring that in. But the main question at this point in time with GeoEvent versus Velocity is whether you want to run on enterprise or whether you want to deploy it as software as a service. Does that answer your question, Phil? Okay. Sure, so the question was, Velocity is not offered as a software at all. At this point in time, no, it's not. It's something that our team's definitely looking at from an R&D perspective, but it's not something that we're ready to put a specific timeline or release date or anything on. It's being looked into.
Here's a question. If I'm using gRPC, is it a requirement that I have reflection turned on my services, or will it allow like a pro definition? Yeah. Help Velocity know.
Sure. So the question was, if you're using gRPC, do you have to have, was it reflection turned on? Or I don't have a specific answer to that, but if you visit us over at the booth, we have developers there who could answer that specifically. Sure. So the question was, do we have any samples with Kafka integration with Velocity? So Kafka is a very common feed type. I don't think we necessarily have any samples available in the documentation, but when you configure a Kafka feed with Velocity, It's basically just put in your broker information, put in your port, put in your security information, and Velocity will connect to it for it. So we don't necessarily have samples for that, but it's pretty much just plug and play to put in your information, and then Velocity establishes that connection to Kafka to stream data into Velocity. We had a question from the chat online. Are you able to export this data in a report style format? I didn't have enough time to really kind of expand on that. I'd want to explain that a little bit more. So Velocity has a lot of different output types. Of course, the most common one we see is feature layers, right? Because people are trying to bring data into the ArcGIS ecosystem and they want to see it on a map. They want to interact with it spatially. But there's a lot of other output types that we have available too. And there's not a specific output type that converts your data into a report structure, but there are various different offerings where you have arcade control over how your data is exported. So that could be going out to an HTTP output, or building data into fields with specific values, or configuring an SNS or SQS message to Amazon, or even an email or text message output, where you can basically use an arcade expression to kind of configure the flow of data, pull data from attributes and so forth. But I don't want to misrepresent anything. It's not necessarily an official report or a document output or anything like that. That's potentially an area of future expansion, but you do have different levels of control over your data before it goes out to various outputs. Oh, sorry. It's hard to see with the lights. Sure. So the question was, currently they use GeoEvent to send and can't use images correctly. Yeah, is Velocity held to the same limitation? So right now, as of today, Velocity does have an email and text message output that connects to an SMTP server. It does not send images. We actually have an enhancement plan for the future, but we don't have a specific date around it now, of offering users basically an HTML configuration of their email output. That's something that, so images don't flow through Velocity, right? We're working with vector data, tabular, points, lines, polygons. There's really no support right now for images to flow through that as part of a record entity. That's not something that's necessarily going to stay the same forever. That's something we could explore in the future as a feature. But at this point in time, right now, no. Other questions out there? Okay, well, we're going to stay up here. You're welcome to come up and chat with us if you want to talk about cases in more detail. We're also over there in the expo in the spatial analytics area. We have a GeoEvent booth and a Velocity booth. And if you want to come up and talk to us about your specific organization and your goals and what you want or the questions you have, that's what we're here for. We'd love for you to stop by and talk to us. Thank you all for attending. Thank you.